In this section, we will discuss about the packet flow between endpoints that are communicating in the same subnet with the ARP flooding option enabled under the BD. In our previous section, we had discussed a similar scenario, but in that the ARP flooding option under the bridge domain was disabled. To understand the flooding behavior in ACI, we need to know about the FTAG trees. So let's discuss about the FTAG trees in the ACI Fabric. So one of the spine switch will be picked up as the root. So let's suppose that spine 1 is picked up as the root switch. And from this root switch, then branches will be spread to the remaining leaf switches. So for example, let's say from spine 1 to leaf 1, this is the link, or this is the branch that is spreaded. This is from spine 1 to leaf 2, and this is from spine 1 to leaf 3. So this is how the FTAG tree is formed within the ACI Fabric. So one of your spine switch will be considered as the root switch, and then branches will be spread, and one of the branch will be attached from one of your leaf switch to the spine switch, like this. Basically, FTAG trees are used to avoid the duplicacy of flood traffic or to avoid loops in the fabric. Also now, you may think that the other links might not be utilized as they are not a part of FTAG tree. For example, this link and this link, which are connected to spine 2. So now you may think that the flooding is not proper in our ACI Fabric, and some of the links, they may not be utilized. So to overcome this problem, we can have 16 FTAG trees. So in total, we can have 16 FTAG trees in the ACI Fabric, so that all the links can be utilized properly. So now, leaf switch, let's say it gets the traffic, and based upon the option which is ARP flooding under the bridge domain, because it is enabled, so leaf 1 decides to flood it. So now, based upon the hash algorithm, it is going to choose one of the FTAG trees. So as we know that there can be 16 of the FTAG trees. So the values of FTAG trees will be from 0 to 15. So it means that there are 4 bits, right? So 2 raised to the power 4 is equal to total 16. So for FTAG trees, there will be 4 bits. So now leaf 1 is going to decide that which FTAG tree it is going to be used for this traffic that is going to be flooded. So based upon the hash algorithm that is run in the background on leaf 1, it is going to pick up any of these random numbers from 0 to 15. So now, because we have 16 FTAG trees in total, and the main thing that we need to know is that in this particular packet, the field we already discussed are these in our previous section. We know that what is going to be put in the VXLAN header and everything. So the main thing that we need to know in flooding is this portion. So this portion in the flooding is called the GPO, group IP for the outer header. So this is the BD multicast address. So the main thing is that it is a combination of the BD multicast address plus the FTAG tree value. If you remember, we had assigned some parameters during the epic initialization phase, like the pod ID, the infra VLAN, tab pool, etc. in those parameters, there is a BD multicast range field also, right? So we assigned the BD multicast range also. So whenever we create a bridge domain, a multicast address is assigned to that BD from that range. So GPO will be a combination of the BD multicast address plus the FTAG tree value. So the FTAG tree value will be from 0 to 15. If you check the BD multicast address, so to find out what exactly is the BD multicast address of a particular BD, if you open the BD in the Epic GUI, and on the extreme left hand side, there is a tab called Advanced. In the Advanced tab, you will find the BD multicast address. And in that BD multicast address, the last 4 bits are always 0 because these are reserved for the FTAG. So in the GPO, there will be the BD multicast address plus the FTAG tree ID from 0 to 15, right? And this FTAG ID value is important for the Fabric devices because they will be following the same FTAG tree for the flooding of traffic. So when this particular packet is received by the spine switch, it is going to check the FTAG value. So based upon the FTAG value, let's say leaf 1 decides FTAG 0, and this blue one is our FTAG 0. Okay, this is our FTAG tree number 0. So after checking this FTAG value, spine 1 is going to flush this particular traffic to all the branches which belongs to this particular FTAG tree, which is FTAG tree number 0. So all the leaf switches are going to receive this particular traffic. And now you can see that on leaf 2, once leaf 2 is receiving this particular traffic from spine 1, because on leaf 2 we do not have BD1 because this particular traffic is for BD1, right? In the GPO we have BD1 multicast address plus the FTAG values. So because on leaf 2 we do not have BD1, that is why leaf 2 is going to drop this particular traffic. And also if you go to leaf 3, because on leaf 3 we have BD1, so leaf 3 is going to flush this traffic to the endpoints. But on the endpoints, if you see on endpoint 2 here, this particular traffic will not be received because leaf 2 is going to drop this particular traffic because there is no BD1 on leaf 2. So now leaf 3 is going to flush this traffic to endpoint 3, and this is how the broadcast traffic traveled from one endpoint to another endpoint in the ACI Fabric when the ARP flooding option is enabled. The last point that I would like to discuss is that you may think of this particular branch, that what is the use of this, right? So let me clean it a bit. So there is a possibility that this particular broadcast needs to travel to other ports also. Maybe you are using the multi-port scenario, and this particular setup via the IPN network, it is also connected to maybe some other port, let's say port 2. So that is why if this particular branch is not connected, then your broadcast or your flooded traffic is not going to be reached in port 2. That is why this particular branch is important. So this is how ARP flooding works in the ACI Fabric when your endpoints are communicating in the same subnet. In our next section, we will discuss about the communication between endpoint 1 and endpoint 2, which are in a different subnet.